This is section 1-2, properties of real numbers. And we're going to talk about different types of numbers. The first one I want to talk about are natural numbers, sometimes referred to as counting numbers. Those are the first type of numbers you learned how to count with. 1, 2, 3. So that's why they're called counting numbers, but also natural. So, for example, the number 3 is a natural number. Because it's a natural number, it's also whole, integer, rational, and real. So you would list all of those things if you were asked to classify the number 3. The number 0 is actually the only number that's a whole number, but not a counting number. If you had, say, -5 is an integer, -1 is an integer. You can think of integers as whole numbers and their opposites. -5, because it's an integer, it's also rational and it's also real. So as soon as you identify the innermost section, it's all of the things outside of that as well. But notice those are not including this little box over here. The rational numbers are things like fractions, like 2/3, or 0.12, a terminating decimal. You can rewrite this as 12 hundredths. And anything that can be written as in fractional form like 2/3 is a rational number. 0.3 repeating, which is a repeating decimal, is also a rational number. You can write this as 1/3. You can have negative rational numbers, like -1/4 is a rational number, also a real number. Now keep in mind, 3 is all of them: natural, whole, integer, rational, real. Irrational numbers are things like pi, which is a non-repeating decimal, or the square root of 2, which can't be simplified. And if you try this on your calculator, it's a non-repeating decimal. Now notice they said the square root of 36 was a whole number, which it is, because it's equal to 6. It's also a natural number, so we can actually put it in here. It's a natural number, which is also whole, integer, rational, and real. So let's try this first one. Name the sets of numbers to which the square root of 6 belongs. Now it might be helpful if you looked on page 11 in your textbook. The square root of 6 is irrational, which means it's also real. So you would list irrational and real. Name the sets of numbers to which 5 belongs. Well, that's a counting number or a natural number. So because it's a natural number, it's also whole, integer, rational, and real. So it's all of those. Name the sets of numbers to which -2/3 belongs. Well, it's a negative, but that doesn't make it an integer because there's a fraction there. So it's rational and also real. So go ahead and try this. 3/5 belongs to which sets? You can pause this, come up with your answer, and then go on. You should have said rational and real. Try this one. -2.52 repeating. Now remember what I said about repeating decimals. You should have come up with rationals and reals. Next one, the number square root of 5 belongs to which set? And you should have irrational and reals. Sorry, I forgot to remind you, but remember on all these check your progress problems, you need to write down the problem. These didn't have work to show, but you would need to write down the problem and the answer. What I want to talk about now are some properties, some real number properties that we have, and make sure that you are familiar with them. The commutative property says that when you're adding or subtracting, or I'm sorry, adding or multiplying, that the order doesn't matter. You'll get the same answer. A plus B equals B plus A. A times B equals B times A. The order doesn't matter. Now I started to say subtraction, but you know that A minus B isn't the same as B minus A. So subtraction is not commutative. Division is not commutative either. But addition and multiplication, the order doesn't matter. That's called the commutative property. The associative property, think of grouping. You can change the grouping in addition, but it doesn't change the answer. If I add the A plus B and then later add the C, that's the same answer as if I add the B plus C and later add the A. Same thing is true for multiplication. The identity property says that if you add 0 to a number, you get the same number back. That's the identity. The multiplicative identity says if you multiply a number by 1, you get the same number back. So that's what you need to remember for identity. Inverse for addition says that if you take a number plus its opposite, you'll get 0, which remember was the identity. So think of the word opposite when you think of additive inverse. When you think of multiplicative inverse, this says a number times its reciprocal equals 1, which is, remember, 1 is the identity. So think of the word reciprocal when you think of multiplicative identity. Closure just says that if you add two real numbers, you get a real number. And if you multiply two real numbers, you get a real number. And the last one here is the distributive property. So if we have A times the quantity B plus C, we can multiply the A times B and then multiply the A times C and add those things together. We can add first and then multiply, or we can multiply first and then add. You can even distribute from the back. You can multiply A times B, or you get BA, and then multiply the A times the C and get CA. So let's try naming this property. Name the property illustrated by. Now look at what's changed. Instead of a negative 8 plus 8, we now have 0. So we've taken a number plus its opposite. Well, that was, well, it won't show up here. That was the additive inverse property. And that says a number plus its opposite is 0. So this is the additive inverse property. Okay, you're going to go ahead and check and pause this. Remember, you're writing this down, writing down your answer, and then checking it. But this is one of the things I'll expect to see tomorrow. You should have said the identity property of addition because you're adding 0 and it doesn't change the identity of the number. So it's the identity property. Additive and multiplicative inverses. Find the additive inverse and the multiplicative inverse for negative 7. Remember that additive inverse, I said to remember opposite. So the additive inverse for negative 7 is positive 7 because it's the opposite. Multiplicative inverse, remember I said to remember the word reciprocal. So to find the multiplicative inverse, you have to flip it over. So you end up with negative 1/7. So the additive inverse of negative 7 is positive 7 because it's just the opposite. The multiplicative inverse of negative 7 is negative 1/7 because it's the reciprocal. So that would be the answer. You go ahead and try this. What is the additive inverse, or the opposite? And what is the multiplicative inverse, which is the reciprocal, for the number 5? You should have come up with the additive inverse, or opposite, is negative 5. The multiplicative inverse, or reciprocal, is 1/5. Distributive property. Suppose Audrey went to a post office and bought 8 42-cent stamps and 8 27-cent postcard stamps. What was the total amount of money Audrey spent on stamps? Not a big deal of a problem. You could all do this without any difficulty. I just want to illustrate that there's two ways you can find the total amount spent on stamps. You could multiply first and then add. So you multiply the price of each type of stamp by 8 and add. So you get 8 times 42 cents plus 8 times 27 cents, and you come up with your total. The other option is to add and then multiply. So if you do it that way, you're adding the prices of both kinds of stamps, and then you're multiplying the total by 8. And you get the same answer, $5.52, regardless of which method. That illustrates the distributive property. You could either add first and then multiply, or you can multiply first and then add. You try this problem, which, remember, that means you don't have to write down all the word problems, but you have to write down a little bit of this, write down the numbers, and let me know how you got your answer. So think about whether you multiply first and then add it, or did you add first and then multiply. Regardless, you should get the answer. Okay, it's not, there we go, $4.44. All right, simplifying an expression. To simplify this expression, you're going to use the distributive property. So to solve this problem, we're going to use the distributive property. So the first thing I would do is I'm going to distribute the 4 to the 3a and the 4 to the b. And I'm going to multiply. 4 times 3a is 12a minus 4 times b is 4b. Then we have plus. We're going to distribute the 2 to the 2 and to the b and the 3a. So we get plus 2b plus 6a. The next thing we're going to do is combine like terms. Now you can reorder if you want to. So you could rewrite it as 12a plus 6a minus 4b plus 2b because the commutative property lets us do that. But generally I just say here's a 12a plus a 6a, which is 18a. And then we have a negative 4b plus a 2b, which gives me negative 2b. And that's the answer. So that's fine to do it that way. Distribute and then combine like terms. But you got to watch out for one like this, because when you distribute, you have to be really careful with this minus sign, because you're distributing a negative as well. So 2 times 3x is 6x. 2 times 1 is 2. We have a negative 5 times x, so we get minus 5x. And a negative 5 times a negative 3, so we get plus 15. So be careful with when you have a negative sign in the middle when you are distributing. Then you just add 6x plus negative 5x, we get x, and 2 plus 15 is 17. This is the last problem, so you go ahead and show me that you can do this. So copy the problem down, work it out, and then click play to check your answer. And you should have gotten 14x plus 10y. And that's it.